Alrighty, last video for the fall semester, you lucky dogs. So we're going to do 6-6 today, solving our radical equations. Our objectives are pretty simple. We're going to solve radical equations. Woohoo! Alright, so I'm just going to do a bunch of different examples for you today. This should be a fairly short video, and then you can start working on your problems. Alrighty, so all of these are going to say solve. So the first one is the third root of 2x plus 7 is equal to 3. So to be able to undo the root, I'm going to raise this side to the third power, and I'm going to raise this side to the third power also. So then I get 2x plus 7. 3 to the third is equal to 27. You can do this in your calculator if you don't know those numbers. Now I'm going to solve this little equation. 2x is equal to 27 minus 7, which is 20. And x is going to equal 20 divided by 2, which is 10. So my solution is x is equal to 10. Alrighty, second example. Okay. The next one is going to be the cube root of x minus 9 is equal to a negative 1. Okay. So the first thing that I'm going to do is isolate my variables by moving the 9 to the other side. So I'm going to get the cube root of x is equal to a negative 1 plus 9, which is 8. Again, I have a root, so the opposite of a root is a power. So I'm going to raise this one to the third power, and I'm going to raise this one to the third power. Okay? So on the left-hand side, I get x. And I don't know what 8 to the third power is, but I have done it already on my calculator, and I get that x is equal to 512. Alrighty, next example. So we're just going to cruise through these fairly quickly, and I'm going to try to do several different examples of different types of problems for you. Alright, the next one is 4x to the 2/3 power is equal to 36. So the first thing that I'm going to do is divide both sides by 4. And I get x to the 2/3 is equal to 9. Now I have to do the opposite of the 2/3, so I'm going to raise this to the 3/2, and I'm going to raise this to the 3/2. Okay, let's scoot our page up a bit. Okay, on the left-hand side I get x. The square root of 9 is 3 to the third. X is going to equal 27. Okay, alrighty. Now, you might notice that I forgot something. This is an even root, therefore, my answers are plus and minus. All right, next example. The next one is going to be the square root of x plus 25 is equal to 4. Notice there's no index, the little number right here, so that means I'm just taking a square root. So I'm going to raise both sides to the second power. And I get x plus 25 is equal to 16. I'm going to subtract the 25 to get a negative 9. So I have x is equal to a negative 9. Alrighty, next example, cruising right along. Okay, this one I'm going to do x plus 2 raised to the 3/4 power minus 1 is 7. So the first thing that I'm going to do is take that 1 to the other side. So I'm going to get x plus 2 to the 3/4 is equal to 7 plus 1, which is 8. Now I'm going to undo the rational exponent by raising everything to the 4/3 power, and I'm going to raise this guy to the 4/3 power. So on the left-hand side, I get x plus 2. The third root of 8 is 2. Raised to the 4th power is 16. Okay, so that's very polite. Subtract the 2, so I get 16 minus 2, and that's equal to 14. Now when we're doing these, if you're struggling with doing this math by hand, you could do it in your grapher, but once you kind of start understanding that 8's third root is 2, it starts to make these things go a little bit faster, but you can do them in your calculator if you need to. Alright, my next example is 2 to the third root of x minus 3 is equal to 4. The first thing that I'm going to do is divide both sides of the equation by 2. So I get the third root of x minus 3 is equal to 2. The opposite of the root is the power, so I'm going to raise both sides to the third power. And I get x minus 3 is 8. 2 to the third is 8. Now I'm going to add 3 to both sides, so x is going to equal 8 plus 3, which is 11. So I get my answer, x is equal to 11. And remember, we always want to identify our answers. And if on the tests, when you can put them in a box, you're good to go. But in this particular case, I'm going to put them in a box, okay? All right. I have 2 more examples for you, and then we're done. All right, in the next example, it's a little bit more entertaining, okay? We like entertaining math problems. So on the left-hand side, I'm going to have x plus 1. And on the right-hand side, I'm going to have 7x plus 15. So since I have a square root on the left-hand side, I'm going to need to square both sides. And I'm going to remind you of the shortcut for squaring a binomial. If I have a plus b squared, I'm going to square the first term, multiply these 2 guys together, and double it, and square the last term. So at this point, it's really helpful if you can start learning this, because now we'll be able to do this more quickly. So on the left-hand side of the equation, I'm going to get x squared, multiply those 2 together and double it. 2x square the last term is equal to 7x plus 15. Alrighty, so now I'm going to combine all my like terms. So x squared plus 2x minus 7x plus 1 minus 15 is 0. Okay, combine all my like terms. X squared minus 5x minus 14 is 0. Now I have a quadratic, and I know that I can solve those by factoring. So I'm going to factor this to be an x minus 7 and x plus 2, because a negative 7 and a positive 2 is a negative 14. A negative 7 added to a negative 2 is a negative 5. My 2 solutions then are 7 and a negative 2. But sometimes a weird thing happens when we do this math, and we might get something called an extraneous solution. Weird word. And basically what an extraneous solution is even though I can find 2 solutions algebraically, both of those solutions may not work. Okay? So I'm going to check both of my solutions. So I'm going to substitute these values back into the original equation. All right, so if I substitute the 7 first, I'm going to get 7 plus 1, quantity squared, is equal to, and this is what we're checking, 7 times 7 plus 15. Okay, and I'm plugging it, oops, I'm sorry, I don't need to do this. Okay, because that was how I solved the equation. So on the left-hand side, I get an 8. On the right-hand side, I get 49 plus 15. So I'm wondering, is 8 equal to the square root of 64? And I get 8 is equal to 8. So that works, okay? So now I'm going to test the negative 2. Okay, so the first one works, so I'm going to substitute in the negative 2. So if I substitute the negative 2, I get negative 2 plus 1. We're wondering if it equals 7 times a negative 2 plus 15. On the left-hand side, I get a negative 1. On the right-hand side, I get a negative 14 plus 15. And a negative 1 is equal to the square root of 1. The square root of 1 is plus or minus, but not all of the roots are negative. Therefore, the negative 2 is extraneous. Okay, so in my solutions, I would put an X through that to show that it doesn't work. And my only solution is X is equal to 7. Alrighty? Alright, I think we're good to go now with your problems. I'll move my paper up just a second. Okay. So now we're ready to do your problems. Probably the shortest video on history for you guys. All of them say solve, and you're going to want to check for extraneous solutions on the last problem, but I'll remind you when we get there. Number 1, you're going to do the square root of 3x plus 10 is equal to 8. Number 2, you're going to do the cube root of x minus 16 is equal to 2. Number 3, 1/2 x to the 5/2 is equal to 16. Okay, number 4, we're going to have 8x in parentheses to the 4/3 plus 44 is equal to 300. And your last problem is the one where you want to check for extraneous solutions. That's such a cool word, extraneous solutions. Okay, and this equation is going to be x is equal to the square root of 16x plus 225. So remember, I want you to check for extraneous solutions on the 5th problem. Alrighty, took a whole whopping almost 11 minutes. You guys are awesome. We are done with our information for the first fall final, or for the only fall final. So good luck, and I'll see you in class tomorrow.